Go. Go. We can see this is rotational motion because it has the three components needed for it to be rotational motion. It has angular displacement, which means the angle it's turning at. It has angular velocity, which means it's the speed it's turning, and angular acceleration, which means the amount it's speeding up or speeding down over time. And because of gravity, we can see it is increasing over time because gravity is acting upon it. Right here we can see rotational motion is still in place, but the angular displacement and the angular acceleration changes because there is no angle, therefore gravity is not acting upon it. The rotational motion taking place in this is very similar to the first one shown because gravity is changing the angular acceleration and angular velocity, and where the golf ball is sliding, since it's on a slant downwards, it increases the angle it's turning on. We can see how this example is very different from all the other rotational motions because there is no force acting against gravity, meaning the angular acceleration, angular velocity, and angular displacement will be greatly increased. Right here we also have rotational motion, but because the object is not going down an angle, the angular displacement, angular velocity, and angular acceleration decreases. This rotational motion is very similar to the last. The angular displacement, angular velocity, and angular acceleration is small because it is not going down an angle. The only difference between these two would be the radius, and that would make the difference in the rotational motion.